Okay, so this next set of problems here, all having to do with sides, is going to kind of level you up as you go through. It's going to start out with some things where we're just kind of picking out sides that go together, and then we're going to talk about scale factors, and then after that, we'll actually find some sides and figure out what's going on. So, number one rule: similar figures do not have congruent sides. If you start setting sides of similar triangles equal to each other, you are guaranteed to get every single one of them wrong. Okay, sides of similar triangles are not congruent. You have to set them up in proportion every single time. All right, so please don't set any of these sides equal to each other. It won't work. All right, so then they've got a scale factor, which you're going to see abbreviated as an S and an F a lot of times. This is how you find a scale factor. So it's side of original triangle over side of the new triangle. Sometimes it doesn't really tell you which one's the new and which is the original. So we'll talk about that as we go on through and try some of these problems. Make sure you do at least a handful of them before you jump right into the next section, where you find where you're actually finding some sides. This thing says the scale factor can be any pair of corresponding sides because we talked earlier in the unit about the fact that if triangles are similar, all the sides will share a common scale factor. All right. What we're going to have to do is we're going to have to set proportions up to answer these questions. So we have to set proportions up. Proportions are two fractions that are equal to each other. And in those fractions, the things that are being placed in those fractions have to match up. I prefer to always set my proportions up. Side of smaller triangle divided by side of larger triangle equals side of smaller triangle divided by side of larger triangle. You do not have to do them that way. But if you not if you should pick a way that you're always going to do this, and then you should set your proportions up that way every single time. I suggest this method just because I think it's the easiest one. All right, but make sure that we have a way that we do them all the time because setting up proportions can get very confusing very quickly if we don't. Because if you have the scale factor, use it in place of one of the fractions. All right, so if I have a scale factor of 2 over 3, then I can put that as one of my fractions and then set it up on the other way. Be careful if your scale factor is 5 over 2. That means that your larger triangle would need to go on top. All right, and then this is the big one. We did this for the angles, but it's extra important for the sides. Make sure that you line up the triangles, the letters of the triangles. That's what that means, the letter of the triangles. Make sure that the stuff goes in the proper fractions. All right, so just a really quick thing. If it said triangle AXP is similar to triangle ZWB, you take the letters of one of them and pair them up like this, so you can tell which sides go together. All right, and this set of problems can give you some practice in doing that, and then picking out which sides go where.